In the heart of every electronic device, there lies a key player that makes it all tick. That key player is the humble capacitor. Capacitors are like the unsung heroes of the electronic world. They store and release electrical energy, filter out noise, block direct current while allowing alternating current to pass, and perform various other functions that keep our devices working smoothly. But what happens when one capacitor isn't enough? That's when we bring in their friends and create a series combination of capacitors. Just as a team of superheroes is stronger than a single one, a series combination of capacitors can accomplish tasks that a single capacitor can't handle. To understand the series combination of capacitors, think of it as a chain. Each capacitor is a link in this chain. The current has to pass through each capacitor, one after the other. This is the same as saying that the current is the same through all capacitors. The ability of this chain to store charge, however, is different. It's inversely proportional to the sum of the reciprocals of the individual capacitances. In simpler terms, the total capacitance in a series combination is less than the smallest capacitance in the series. When capacitors are connected in series, the total voltage is the sum of the voltages across each capacitor. This is because each capacitor gets a share of the total voltage. So if you have 3 capacitors in series and apply a total voltage, each capacitor will have a portion of that total voltage across it. The energy stored in this series combination is the sum of the energy stored in each capacitor. This energy is equal to half the product of the capacitance and the square of the voltage across each capacitor. But remember, the total energy stored in the combination is not the same as the energy that would be stored if the same voltage was applied to a single capacitor with the same total capacitance. To summarize, a series combination of capacitors is like a chain where the current passes through each capacitor sequentially. The total capacitance of this chain is less than the smallest capacitance in the series. The total voltage is the sum of the voltages across each capacitor, and the total energy stored is the sum of the energy stored in each capacitor. So, the next time you use an electronic device, remember the series combination of capacitors. They're the unsung heroes that make it all possible. They may be tiny, but they're mighty, and they're working tirelessly behind the scenes to keep your devices running smoothly.